Nabisco. So she was putting cheese in. I'm not a big fan. Brie. You guys like
What?
Brie?
Brie was saltine.
Brie has saltines
I
on
don't know. Maybe she's pregnant. I don't know. She's not telling me. Guess I'll find out. Okay, this is the Parrot-Logit stuff. We already know that. Yeah, you can do that, but it's okay. So again, we got to create the choice variable. The data as it comes from Nielsen and IRI isn't in the format for us to analyze using these tools. So we have to generate this choice variable. Remember, it doesn't matter the order. So I chose a specific order. I chose alphabetical. And this is going to come in handy when we use margins and margins plots. So I just chose KNPS. I labeled them, but remember some of the outcomes are going to be outcome 1, 2, and 3. So if they're always alphabetical, or then, which is what they are, I'll just remember what it is. So as opposed to kind of picking some random order. So I just chose alphabetical. It doesn't really matter. We did all this stuff. This is just kind of showing off that we can use the formulas that I showed you that we're never going to use to get the probabilities. These are the margins. The relative risk ratio is nice because it's just that option, triple R. So again, the nice thing about the relative risk ratio is that it actually makes some sense. You're 1 times more likely or 2 times more likely, but here you're less likely to pick Keebler than Nabisco. You're 0.12 times less likely to pick Keebler than Nabisco. Again, it's always relative to the base. You're 0.57 times less likely to pick private label than Nabisco, and similarly with Sunshine. If we change the base, we can see that. Let's change the base to, looks like 1. One is Keebler. You're almost 8 times more likely to pick Nabisco relative to Keebler. You're 4.5 times more likely to pick private label over Keebler. And it's almost equal odds, which we knew from the relative frequencies. But you're a little bit more likely to pick Sunshine over Keebler, but that difference is not statistically significant. Small t, big P, insignificant. I think what I'm going to have you do is just look at the marketing values. So here's everything. Here's the whole kit and caboodle. We got prices, we got this feature, we got display, we got feature, and we got feature and display. Exactly. This is nasty looking. There's just, what we want to do is we want visuals for this. What we can do is kind of check, again, the laws of demand. For Keebler, is the price of Keebler negative and significant? Yes. For Nabisco, is the price of Nabisco, this one I can reach. For Nabisco, is the price of Nabisco, no, that's the, I'm sorry, that's the base outcome. For private label, is the price of private label, is it negative and significant? Yes. Law of demand holds for Keebler, law of demand holds for private label. We can change the base to look at Nabisco, but we'll probably be happy with it. And for Sunshine, we can see the price of Sunshine is negative and significant. And then we know the own promotional effect should be positive. The cross promotional effect should be negative. All right, let's kind of visualize some of this stuff. if we go back to that paper price promotion, we know that we should probably interact these things. And theoretically, we probably should. Unfortunately, this model doesn't converge. This says after 2,000, but I think you can go after 5,000 also. It'll just keep running all night long. And so we can't run, remember price, the whole idea between interacting price and promotion was that in that original paper, the whole idea between interacting price and promotion was that, you know, if we don't interact them, it's assuming that those two demand curves without promotion and with promotion are the same. They look the same. But if we allow price and promotion to interact, then we allow a difference in the elasticities, so with promo. So that's why we interact price and promotion. Here, these are just dummies. So technically, we're just running these parallel demand curves. We should interact price and promotion. We're limited right now by the fact that if we run those interactions, and again, we don't have to necessarily do this, but if we run these interactions, I don't know how long it'll keep running, but it'll keep running. And eventually, it'll just say unable to converge. I stopped it at 5,000 iterations. And sometimes you can't, so we can't run those interactions. That's fine. Let's check the law of mean. So here's our regressions, the same regression we ran before. Remember, margins and margins plots is a post-regression command. Check the law of demand for Keebler. Outcome 1. Yeah, outcome 1. Over the price of Keebler. Okay, there's our margins, which ran.
And the outcome number, that's based on the regression results, correct?
That's based on the regression results, and it's also based on how we defined our choice variable. So remember, what I did was I defined them. This is remember, these are just numerical 1, 2, 3, and 4. But I defined them alphabetically, so 1 was K, 2 was N, and so on and so on. So outcome 1 is going to be Keebler, outcome 2 is going to be Nabisco, outcome 3 is private label, outcome 4 is Sunshine. If we're looking at the own price effects, you want to run them across their own price. So for outcome 1, which is Keebler, I run it across Keebler. And we should get a nice, not that, but a nice downward sloping demand curve. Probabilistic. Yep. Because I ran that tab. Remember, margins plots is a post margins command. Let's see if it asks me to run the regression. Here we go. Good looking graph. We can construct this similar graph. So now we want to look at the own price effect for Nabisco. So it's outcome 2, and we want to run that against Nabisco. So we want that. That looks nice. Private label is 3. And again, we're going to run that against private label. And we're going to want to look at those cross price effects. And you can see private label's not getting the full range because essentially what this is saying, what does this say?
They're less price sensitive, splatter.
It's saying even at a price of 0, the probability of someone purchasing generic crackers is at its max going to be 61, 2%, something like that, even at a price of 0. So there are some people that if they were giving away generic crackers at Safeway, you would still buy Nabisco or some other brand. You're still not going to, you're not going to grab the free box of Safeway brand crackers. That's awesome though. That is a great insight because,
They're
By the
probably
way-
made by Nabisco anyway.
or yeah, by the way, this is probably one of me. Why would I not like generic crackers when I don't even like crackers to begin with and it doesn't really matter? I don't know, because I'm stupid like apparently some other people. So, yeah, so, you know, think about this. You're at, you're at Costco and they're giving away a pair of shoes. I'm looking at the women, but I'm trying not to look at the women. You know? How many of you would wear Costco shoes? You would? Free? Even if they're, yeah, exactly. If they're giving away, you wear Costco shoes?
The Kirkland shoes?
Yeah.
Yeah, totally.
Really?
Yeah.
I wouldn't.
I mean, they're probably made in the same factory as Nike.
Yeah.
They're
But
Crocs.
still, they got that Kirkland brand
They're
and they're
Crocs.
giving them away.
Kirkland.
But we have 2 people here, or 2 women here, that wouldn't. It's a 50-50 shot here. So what we're saying, you know, that would cross at about 0.5. Yeah, some people are just not going to wear them. I don't care what the price is. So I don't care what the price is. You know, there are some products I won't buy. Cupcake wine, for example. I'm just not going to drink it. No. I'm going dry. I'm designated driver tonight.
Wow.
I'd rather, exactly, wow.
That's saying a lot.
I'd rather drive than drink cupcake wine. Now, I shouldn't say that, because I will buy cupcake wine if, like, there's company and that I don't like. It's like, okay, you
Cheap.
get
Get out.
go to town, you can have all the cupcake wine you can.
The in-laws are coming over.
But even that, I didn't buy it. The one night I did that, it was somebody brought it, and I put that out for the people that I didn't want to be there. So I figured they'd see cupcake in there. I'm out of here. Bummer. Then we'll pull out the good stuff. As soon as you leave, you're. Don't tell me I'm the only one. That does that. I know everybody does.
Get a keys.
All right, so here is, this is Sunshine. And again, these are the premium brands, so you're probably going to get a fuller, yeah, 0.8, but it's still not up to 1, but you know, you're getting a fuller S shape here. But it makes sense that generic brands, some people just won't buy generic. I haven't had a generic beer since college, undergraduate college.
I've heard Kirkland brand is good.
Beer? They have a beer now?
It is.
Cans.
It's good.
Apparently
In a
it's
can.
good, but I don't know.
the cans with the bottle.
You know what's good is the Kirkland vodka. The
Don't.
Kirkland vodka is good. What's that?
It's not.
It's not Grey Goose,
No.
but
It's still good.
but it was designed to taste like Grey Goose. So you know who makes it is, I think I told you, I'm not supposed to tell you, especially on camera, but it's Winery Exchange up in Nevada. So they make that for Costco, and they were kind of given a task by Costco. We want to specifically compete with Grey Goose. So they went out and sourced the wine to make, sourced the vodka to make sure that it competed with Grey Goose. So I did some analytics I do some analytics for Winery Exchange. Here are some cross price or elasticity. Let's go to cross price. This is actually, that's a nasty looking margins, isn't it?
I don't even see any ones. Those are all
Exactly.
zeros.
So what you can do is this. I mean, margins is really powerful, but you can evaluate marginal effects, which we've already done, at specific prices. So this is evaluating a marginal effects, and this is what we're calling quasi-price elasticity, which would be something along the lines of, when we talked about this with Heinz and Hunt's. So normally, an elasticity is the percentage change in quantity demanded over the percentage change in price. But with us, remember, our dependent variable is already a probability. So it's really, what you have is a change in the probability of choosing some brand. This is a slope resulting from a change in price. But if you wanted to have something elasticity-ish, for example, this is pure slope, and we know it's nonlinear, so we're going to get different values, which is nice, which is true about elasticities. But you can do it quasi-elasticity by making this a percentage. It's quasi because only half of it is a percent. So for a 1% increase in price, what's the effect on the probability of choosing the brand? The reason you don't want to put a percentage here, because you don't want to analyze the percentage of a percentage. What's a 1% increase in price, or what is the effect of a 1% increase in price on a percentage change in the probability of choosing a brand that's already a probability? To me, that's awkward. So I think I call these, or I don't know if textbooks actually call them quasi-elasticities. And we can get it pretty easily from just changing this from a dy dx to a dy ex. So again, this is just kind of, and we can evaluate these at different prices. So what I did was just said, look, here are some prices. I'm going to sum Keebler's price. Looks at the 50th percentile is $1.09, the 25th percentile is $1.05, the 90th percentile is $1.25. Mean is $1.12. So we can evaluate these at different prices, and that's all I did here. I evaluated at 99 cents, $1.12, which was the mean, and $1.29. And here's our quasi-elasticities. Now, one way to do this, and again, this is just kind of fun with margins, and margins is all about the fun, by the way, is that we can literally specify at means, and that's there at mean. It'll evaluate it at the mean price. And we can see that that mean price, does it give it to us? Yeah. So let's go up here. That mean price here is the same as the mean price there that we actually specified. But you can go even further. You can evaluate it at different percentiles, and that's what I'm doing here. So I'm setting everything equal to 0, all the promotion equal to 0. But I'm going to evaluate it at 3 prices. At the price of the 10th percentile, which I'm going to say a low price, at the mean, so if you look at this, I'm not going to write on it, which I almost did because I was about to pull the top up. At the 10th percentile, at the mean, and then at the 90th percentile. And those are usually pretty common measures of low prices, high prices, and then average prices. So all this other stuff is just setting everything equal to 0. So we set all the promotional stuff equal to 0. So for a small change in price at the 10th percentile, we see that it'll lead to, for a 1% increase in price, it'll lead to a 0.59 percentage point decrease in the probability of choosing it. At the mean, it's a little bit less, and then at the 90th percentile, it's a little bit less also. So this is just means we can do stuff. All right, so what are we doing here? This is Nabisco doing the same stuff. What we want to do is cross price. Yeah, so here we're doing cross price. Let's do this. All right, so there's our model. We already ran a regression, so we should be fine. So in essence, what I want to do here is look at the cross price effects. So now I want to look at well, this is an own price effect. Outcome one is Keebler, and this is across the price of Keebler. So this is an own price effect. And then this is our graph of the own price effect. So we write that down. All right, that's fine. And what we want to do is compare these suckers, compare some of the own price effects. So we want to save the margins before we get to the cross price effects. We want to save the margins. And essentially what I'm doing here is, look at this first one. Predicting for outcome one over its own price, and I'm setting everything else equal to zero, all the promotional effects equal to zero. So if we don't do, and this is important, if we don't do this, if we don't set all the promotional effects equal to zero, it sets them to their average. And that doesn't make any sense. I think we talked about this with the binary. It doesn't make any sense to have an average display. Either you're on display or you're not on display. You can't be averagely displayed. You can't be averagely featured. You can't be averagely. So if you want to analyze the promotional effects, we'll do that. But what we want to do is kind of hold everything constant and let's set things equal to zero so we're not muddling things up with these average promotional effects, which make absolutely no sense. So I set all those equal to zero, and then I use the saving margins command, which I gotta change here. E, oops.
Is it,
Is that right? Set some off a little bit.
is it always replace or is it replace and append like with?
Oh, yeah, we're not gonna append yet, we're just gonna, I just put the replace in there because these are already generated, I've already run this. All right, so what am I doing? I'm running the own price effects. So remember we wanted to compare those own price effects so we can compare the price sensitivity amongst consumers. And that's all we're doing here. So I'm going to run these, and the nice thing about this is, again, this is copy and paste. I change this from outcome 1, 2, 3. I change this from price 1, 2, 3, which is Keebler, Nabisco, Private, and Sunshine. It's going to save all these outputs. It's thinking, it's doing math, it's dividing by something. So remember, this is going to generate, which we saw earlier, 3 individual graphs that we really can't compare. We want to be able to take those margins and superimpose those graphs on each other. So we have to take those margin outputs, save them, which we did using the saving margin command. And then we're just going to combine those outputs together. So let's see. All right. Let's go to our first margins. Oops, wrong drive. Remember that underscore margins is our predicted outcome for Keebler. And we just need to figure out which one is the price. And we can tell that, usually the first thing I look for is the double. The double is going to tell us the price, because that tells, double has to do with precision. And all the other ones are mostly zeros, so there's no precision there. So at 3 represents the price of Keebler. that's fine. But we're gonna have we're gonna have 4 different margins, so we just wanna be able to rename these. So I wanna rename margins, underscore margin, P Keebler, which is the probability of Keebler. You can call it anything you want. And I'm gonna rename @3 price. Save it. Then I'm going to open the second one. It's already saved it, so I'm good. And the second output should have been second output, let's go to underscore margin, and that is Nabisco. Again, I went alphabetically. And I can see that the price of Nabisco is double, it's @4. So underscore @4. And do the same thing. I'm going to rename margin, because you can't, remember, I want to graph all these on the same graph, so I can't have them all with the same name. So that's why I have to change these names. The nice thing, however, is that all these prices are over the same range. I think it's from 0 to $3 or $2 or whatever it is. And we can actually see that. They're all over the same price because I specified that in my, where's that? In my margins command. Yeah, 0 to $2. So all my prices are over the same range, which is nice. Rename. Boom. Change these. Idea. Did I do this one? Yeah, there's Nabisco, so there's that. And there's the final one. All right. So, I'm currently in category 4, emoji 4. And I'm going to merge, I'm just going to go backwards and merge it with 3, 2, and 1. This is not a append, it's a merge, because now remember append is...
Paper example.
Oh.
Not this side.
Append was that, making it longer. Now we're merging, we're adding variables. So we've got probability of Keebler, probability of Nabisco, probability of sunshine. You guys don't like my visual.
No, we do like it.
So now we're appending. We're making the data set longer. So we're using the merge. I'm sorry. We're using the merge command. We're making the data set longer. So we're doing it. It's a 1-to-1 basis, and we're doing it on the variable price because remember we specified the same, not the same price, but the same price range. These are E, not G. For all of these. All right, so I'm going to merge this. And they should merge perfectly. And every time you merge, you get this little results thing. And matched, there's 201 observations, all of them matched perfectly. None of them did not match, so that's good. And every time you run the merge, it runs this little underscore merge thing. So you need to drop that because you're going to have that every time you merge. So if I run this, you see that it was successful each time. So I want to look at this. I've got all my probabilities. I've got probability of Keebler, Nabisco, private, and where's Sunshine? And that, oh, Sunshine's up there. Sunshine's up there. And I have one price because all 4 products were evaluated over the same price range. So now I can just do a scatter diagram. I don't have to use margins or margins plots. I've already combined those results. So there we go. And this is nice because, again, the default legend tells us blue is Keebler, red is Nabisco, green is private label, and mustard is Sunshine. And we can see
Annie.
didn't erase this. We can see that we can evaluate the elasticities at any given point. All right, if I fall, don't laugh. Well, so we can take, what's this, 75 cents? I'm gonna write on the wall on it.
So we already did.
We're hoping.
So we can do that, and we can take the probability over here, which is roughly 0.4, and let's say we go up a quarter. And we can see which one really has a significant effect. So we can see that as we go up a quarter, look at, we go up a quarter, we see this effect for blue, which is
Keebler.
Keebler. As we go up a quarter, we see this effect for Sunshine. And green is private label. Right, so we can measure these price elasticities. And red, we don't want to write on the wall, like those guys do. Yeah. All right, I gotta get down, that's gonna be the hard part. So we could, again, compare price sensitivity directly without having to kind of divide it from 4 different graphs, which is what we get from margins. So this is already a big improvement for that.
And these lines are with no promotional activity,
Because we specifically set them to 0.
so we set them to 0.
Yeah, if we hadn't done that again, it would set margins by default, sets everything that you don't specify equal to their average. And like we said, that's nonsensical. It doesn't make any sense to have an average display, average feature, and all that stuff. Plus, when we want to evaluate the promotional aspects, we want to be able to explicitly set those to 1s and 0s so that we can see